This is a video for AQA Discrete Mathematics. This is Graphs and Networks section 1.4, where we're looking at minimum spanning trees using Prim's algorithm on a table. Well, we've already seen Prim's algorithm working when we have a graph of a network. Before we go on to look at the table, just to mention the idea that Prim's is an example of what we call a greedy algorithm. Now, a greedy algorithm, and there are many of them, basically chooses the best option at any stage, so always looks to do the best. Now with Prim's algorithm you're looking for minimums, so it always chooses the shortest path at each stage of the algorithm. Well, what we want to do then is, if we haven't got a graph but we've got our information given in a tabular form or a matrix, what could we do? Well, one thing we could do, of course, is convert that matrix into a graph, but in general that's not going to be a sensible option because usually these are far too large. We're normally dealing with quite small tables, but even so it would be quite an inefficient method to use. So we're going to develop another algorithm, or at least develop Prim's algorithm so we can use it on a table form. Well, you remember that Prim's we start at some node. Doesn't matter which node we choose, but quite often in a question that would be given to you. So for example, it might say starting at A. So the first step then is, for that particular node that we're starting with, we number the column, number 1, and we delete the row for that column. The next stage is say, well, where's A going to be joined onto? So we look down the column that we've numbered, that's the first column, A, and find the smallest value, the greedy part of the algorithm coming in there. And we put a circle around that to show that that's the one that we've chosen. So there we would be choosing C. So we would then make a note of that and say that the first one we've chosen was AC and its length 1. We've joined to C, so we now number the column for C, number 2, and delete everything else from the row. Now the reason for deleting from the row is that means that we're not going to be able to join back to C from another node later on. In other words, that avoids the idea that we might accidentally produce a cycle. It then continues going back to number 2. We've now got 2 columns to look at. So we look at both columns 1, A and C, looking for the smallest number that there is there. And you can see that this time it's the 2, which is in B, so that we then label column B as number 3, delete its row, or the rest of the row, and write down that the next arc to be added to our network was from C to B, and it was length 2. We've now got 3 columns to look at, and so we're looking for the smallest value there, and you can see that this time it's here at number 3. So that's E that we're going to join. We're going to go from C to E, weight 3. So we delete the rest of that row, label E as being the 4th one to be added on, it's the 4th node, and then finally we must come down here to the 1, so that our final one to be added is from E to D, and that becomes the 5th node to be added. So 4 arcs 5 nodes making up the minimum spanning tree. The weight of the minimum spanning tree is given by the sum of these, so 1 plus 2 plus 3 plus 1, giving you a total there of 7. So the total weight is equal to 7. So here's another example going through. We'll start at A again. So starting at A, labelling that column there number 1. Looking down, and we can see that the smallest value is 1, so that we then delete row A and the rest of row E, so that our first arc is AE of size 1. We then label column E as being number 2, so that's the second node is E, and then we look down both columns to see that the smallest is the one at the bottom there, so therefore the next arc is EF, again size 1, and we delete the rest of row F and label column F as number 3. This time we're looking down 3 columns, and to find the smallest number we can, there's a choice here. We could either choose the E to D or from F to C. So I'm going to choose the E to D, and that's size 2. Delete the rest of that row and label column D as being number 4. We can then see that we've got a 1 appeared in the column 4, so the next one is to add that 1. So we're going then from D to C, length 1, delete the row for C and label its column number 5. Finally then, looking down there, we can see that the smallest value in all of those columns is the 2, which joins us from C to B. And that becomes B becomes the 6th point to be added. So those are the order that we've added our arcs, and the total weight is equal to 7. Now you have a nice neat version for you to look at. Go through it again yourselves just to make sure that you're happy with the method. And that's probably about the size of the problems that you might expect to get in an exam. Well, like all of these algorithms, there are some common errors that may be made, so you have to be careful to avoid them. The first one is always to make sure you read the question, because the question will often, with Prim's algorithm, ask you to start at a specific node. If you don't delete a row, if you forget to delete a row, then that means that you could possibly join back onto that vertex which has already been chosen, which obviously goes against Prim's algorithm. So always remember to delete the row. This is quite a common one, not looking down all of the columns, so looking at just a few and forgetting one of the columns, and so therefore missing a shorter arc. Forgetting to record the order of the arcs. It's important in terms of the exam question that you do that with your solution, because that's what the examiners will be looking for, that you're applying the algorithm in the correct order. And without writing that down, you would have to then go back and start again, in effect, to remember which order you've added things in. So in other words, not showing enough working is part of that, so that the examiner won't be able to tell whether you've applied the algorithm correctly or not. And then finally, forgetting to just state the length or weight of the minimum spanning tree when you've finished. Well, that's the end of this video. In the next one, we'll be looking at minimum spanning trees again, but this time looking at an alternative algorithm which is known as Kruskal's algorithm.